I will be discussing the problem decode ways. The problem statement says you have intercepted a secret message encoded as a string of numbers. The message is decoded via the following mapping. 1 is A, 2 is B, and similarly 25 is Y, and 26 is Z. However, while decoding the message, you realize that there are many different ways you can decode the message because some codes are contained in other codes, 2 and 5 versus 25. For example, 11106 can be decoded into AAJF with the grouping 1, 1, 10, 6. KGF with the grouping 11, 10, 6. The grouping 1, 11, 06 is invalid because 06 is not a valid code, only 6 is the valid. Note there may be strings that are impossible to decode. Given a string S containing only digits, return the number of ways to decode it. If the entire string cannot be decoded in any valid way, return 0. The test cases are generated so that the answer fits in a 32-bit integer. So the solution code uses top-down recursion with memoization to count all possible ways to decode the string. The dictionary DP stores results for each index so we don't recompute them. The DFS function DFS of I returns the number of valid decodings starting at position I. If I already exists in DP, we return it immediately memoization. If the current character is 0, we return 0 because 0 cannot start a valid letter. Otherwise, we try two decoding options. First one, the single digit decode, always valid if S of I is not equal to 0. So we compute DFS of I plus 1. Second is two-digit decode, only valid if the substring from S I to I plus 2 forms a number 10 and 20 forms a number between 10 and 26, which the condition checks. If valid, we add DFS I plus 2 to the result. We store the result in DP of I and return it. The answer is DFS of 0, the number of decodings starting at index 0. The pattern which is observed while solving the problem decode ways is first one is DP by index on strings. This matters because it helps solves any segmentation or decoding pattern problem. Second one is one step or two step window decisions, where it matters where the same pattern is in climbing stairs problem and house robber problem also. So third pattern is DFS plus memoization, which cuts exponential recursion and which is crucial for DP. Fourth pattern is validity conditions, which teaches handling constraints inside DB transitions. Fifth one is backward subproblem definition. It matters because it is a common DP based technique.